Alright, taking a look at this test that we did in class, 3.1, form follows function. So we're taking a look at some linear and exponential equations, okay? So this first group are some linear, okay? Now the first we often call the slope-intercept form, okay? We've also, these both right here are both explicit, okay? We often have written it a sub n equals 1 plus 1/2 times x, or even f of x equals either way, okay? So there are multiple ways that we can do that. This is kind of the format that is pretty standard. This y equals mx plus b. Point slope, that one's something new, where this one has the y-intercept as its point and the slope. Here now we are given the slope and two coordinates. So they could be a coordinate anywhere on the line. It doesn't have to be the y-intercept. Okay, and it looks like that. Then the recursive formula, we've also seen this as a sub 0 equals 1 with a sub n equals a sub n minus 1 plus 1/2. Remember that tells us the growth and the starting point. Okay. For exponential functions, our explicit form, 8 times b to the x, we've also again written it as a sub n equals 10 times 3 to the x, or f of x equals. Okay, and same with the recursive formula, we can also write it in the a sub 0 equals 10, and a sub n equals a sub n minus 1 times 3. So they kind of flipped it around, which we can see that as well. Interestingly, that's how we're used to seeing it, but you can write it like that as well. Alright, so knowing about these different forms and being able to use them can help us figure out sometimes one works better than the other, okay? And what information do we have? What can we figure out? How can we use that information to model problems better and to work better, okay? So let's take a look here. We've got some situations. We're going to make some equations and decide what kind of function is this, if it's continuous or discrete, okay? And what kind of equation we wrote. So, in his job selling vacuums, Joe makes $500 each month plus $20 for each vacuum he sells. Write the equation that describes Joe's monthly income, I, as a function of the n, the number of vacuums sold. So I equals, he starts out with $500 each month, then we add $20 for every vacuum he sells. Okay, so looking at this one, okay, we just kind of did it backwards, but that's essentially that slope-intercept form. Okay, so we added here, so that's definitely linear, and continuous or discrete. The way to think about continuous is it's something that's always growing. Discrete is it kind of comes in chunks. Like continuous would be water coming out of a hose. It's a constant thing happening. Okay? Whereas discrete would be like if you had a bucket and we're doing a bucket. Now you could continuously be pouring buckets in, but the water, as you move the bucket away to fill it up or grab another one, there would be a stall in it, in whatever you're filling up, being able to fill up, and the water would kind of come in chunks. So think about this. Can he sell a partial vacuum? If he could, it would be continuous. However, you don't sell partial vacuums, so it would definitely be discrete. All right, number 2. Write the equation of a line with a slope of -1 through the point -2,5. A slope and a point, that's definitely going to be point slope. Okay, so we'd go y equals our slope times x minus a -2, which we can just change that to plus 2, plus 5. Okay, again, all this addition and multiplication, which means repeated addition, definitely linear. This one, there's nothing telling us it's discrete, so we're going to choose continuous. And basically, if it, you assume it's continuous unless it says it's discrete. Write the equation of the geometric sequence with a constant ratio of 5 and a first term of -3. Okay, so y equals a first term, not a zero term, right? So with this one, there's really two different ways you could write it. If you wanted to go explicit, then yeah, we'd go y equals, we start at -3/5, because if we're making a table, our first term was -3, so going backwards would be -3/5. Then it would be -15 times 5 to the x. If we wanted to go recursive, which we could, we'd go a sub 1 equals -3, or actually let's do it in function notation. F of 1 would equal -3, then f of n equals f of n minus 1 times 5. Okay, definitely exponential, and we're going to assume this is continuous, because there's nothing here telling us, well, I guess it says a geometric sequence, and if something's a sequence, then it's discrete. Okay, number 4, write the equation of the function below. So we've got a line that's definitely continuous, there's no breaks in it. Our starting point is right there, so we could choose that one. And then we need to figure out how it's growing. So it looks like there's another good point. So as it goes up by 3, to the right 4. So for every 3 that we go 4. So it'd be 3/4 for our slope. So y equals 3/4 x minus 3, because it's a -3 where we start off. Definitely linear. Okay, you could have chosen a point over here and done the point slope, and been fine as well. Okay, number 5. The population of the resort town of Java Hot Springs in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. Write the equation that models the number of people in Java Hot Springs with t equals the number of years from 2003. So what that means is 2003 is like our 0. Okay? So when we have a percent increase, okay, think of this 3,500 as 100%, and we're adding every year 2.4% to that. So we're increasing by 102.4%. Okay, it's going to make it exponential. Since we're told where we're starting with 2003 at 0, okay, and we have 35,000, I would go with the explicit form. You could do recursive, but y equals, we started with 35,000 people, we're timesing by 1.024, because we turn it into a decimal, to the t. Okay, people, now with growth, could we say that that's discrete or continuous? That one's kind of a tough question, but you can't have partial people, so I'd say it'd have to be more discrete than continuous. Number 6, Jessica's science fair project involved growing some seeds to see what fertilizer made the seeds grow fastest. One idea was to use an energy drink to fertilize the plant. She thought, if they make people perky, they might have the same effect on plants. Here's the data that shows the growth. Okay, so we'll write the equation that models the growth of the plant over time. So we've got to figure out how this is growing. So we could be adding, 1.2? 1.7 plus 1.2 would be 2.9, plus 1.2, would that give us 4.1, plus 1.2, yep, so that's definitely a linear because we're adding. Okay, so I could do a point slope here, I could do a recursive, I could do explicit, slope-intercept. If I did slope-intercept, okay, SI will say, you would go y equals, we're adding by 1.2 per week, and we started at, we'd have to go back to 0.5. not 1.5. Okay, if we did the point slope, we could take any of these points, say this one, and go y equals 1.2 times x minus 4 plus 5.3. And if we did recursive, we could do f of 1 equals 1.7, f of n equals f of n minus 1 plus 1.2. So really, it's kind of up to you. Now, plant growth, I would say that's continuous. A plant is constantly growing even though we can't always see it very well. All right, an equation gives us information we can use to graph the function. Pick out the important information given in each of the following equations and use that information to graph the function. So, we've got a minus 5 right here. That's our start, also known as our y-intercept. So it's the point 0, negative 5. So we start out 0, negative 5. Then with the x, that's our growth, also known because it's a linear, it's known as slope. So 1/2, so that means I go up 1 every time I go to the right 2. And I use that to graph my line. And it looks like that. Okay, number 8, we've just got 2 to the n. So same idea, that's really like y equals 1 times 2 to the n. So again, my y-intercept, or my start, is 0, 1. So start right there. Ooh, that was really good placement. My growth, now that's not slope because we're dealing with exponential, is we're timesing by 2 each time. So as I go to the right one, I double my amount. To the right one, I double my amount. And then I keep doubling. As I go to the left, it just hugs right down low. So it looks like that. Okay, number 9. This is the point slope, so I have a point, negative 6, 8. Just a regular point. So right about there. And then negative 2 for my slope, because this is linear. So a negative 2 slope would be like negative 2 over 1. So every time I go down 2, I go to the right 1. Down 2 to the right 1. And I can see that pattern and make my line again. For number 10, I can also see that this one is linear, right? Because it's got a plus 1. This is recursive form. So that plus 1 is my growth. So every time I go to the right 1, I'm going to go up 1. And then my point, I've got a point 1, negative 5. Okay? So 1, negative 5, I start off. Then as I go to the right 1, I go up 1. To the right 1, up 1, and so on. And follow that pattern. Okay? So there's kind of some work with those different types of exponential and linear equations.